listen to part of a lecture in an environmental science class. Now, over the next few weeks, we're going to focus on carbon and its role in what's known as the greenhouse effect. Everyone knows what that is, right? But let's make sure anyway. Yes, Carly?
The greenhouse effect is when gases in Earth's atmosphere act like the glass in a greenhouse or hothouse. They trap in heat, which warms up the Earth.
Gases like?
Water vapor. Carbon dioxide.
Right. Carbon dioxide. We hear a lot about carbon these days, no? Carbon emissions, carbon burning, leaving a carbon footprint. So it'd be easy to assume that any form of carbon burning is necessarily a bad thing. But the fact is, it's not quite that simple. So we're going to focus today on the difference between good, bad, and, well, the not so bad. The potentially okay carbon burning. Okay. Good carbon burning. Well, we all have a personal stake in this because burning carbon is the basis of life. We wouldn't be here if we ourselves weren't burning carbon. Basically, all living things burn carbon to survive. Usually, this happens at the cellular level. And what's burned is carbon in the form of sugars. Glucose. Oxygen gets chemically combined with sugars in our cells. And the energy produced from that reaction is then used to power the cells. So, just by breathing, you could say we're all guilty of carbon emission. And contribute to the amount of carbon in the atmosphere. Another thing about atmospheric carbon. It keeps us from freezing. Because without carbon and other greenhouse gases, our planet would be the same temperature as outer space. Around 4 degrees above absolute zero. And there's nothing going on at that temperature. There's no possibility of life of any sort. So, without atmospheric carbon, life couldn't exist on Earth. Now, another thing to remember is that carbon is always being removed from the atmosphere. It gets used up. Largely, it's consumed by plant life through photosynthesis. Also, it dissolves in the oceans, or gets stored deep in the ocean. So, with all this carbon constantly being depleted from the atmosphere, we really need to keep carbon output up to a certain point. So, why all the bad press for burning carbon? Well, turns out, it's the source of the carbon being burned that's the key. It's in fact the burning of carbon. And the burning of carbon is the source of the carbon being burned. Well, turns out, it's the source of the carbon being burned that's the key. It's in fact the burning of what we call fossil carbon that creates the imbalance. The fossil fuels. The coal, oil, natural gas. These substances are all mine. We have to dig them up or drill a well to release them. And this is carbon that was in the atmosphere millions of years ago. So, what happens is when we burn this carbon, okay, it doesn't really release a whole lot compared to the amount that's already there in the atmosphere, but it adds to the pool. And over years, it accumulates. Think of the atmosphere as a big bathtub. It's basically already filled to the brim with carbon. When we start adding fossil carbon into the mix, it starts to spill over. That being said, there's actually a category that's in between. What we call biomass fuels. Probably the most common one is wood. Another example, on the North American plains, the Native Americans used to collect buffalo droppings to burn. In Ireland, they cut up peat from bogs and they burned that. So, what's the big distinction between this and fossil carbon? Well, biomass carbon is what we might call current carbon. It's always going in and out of the atmosphere. So, if we burn one of these fuels, we're putting its carbon into the atmosphere, right? But in a balanced system, somewhere else in the world, this same amount of carbon is going back. It gets taken in by growing vegetation. So, burning biomass fuel produces sort of not-so-bad carbon. In fact, it can become good carbon if we endeavor, as a society, as humanity, to allow forests to recover this carbon. If we don't, say, pave over all the surfaces to prevent things from growing. So, whenever we cut down a tree and burn its wood, we have to allow another tree to grow to keep things in balance. That way, you're carbon neutral. What is the main purpose of the lecture? A. To argue that carbon emissions today are not the only factor responsible for global warming. B. To provide evidence that rates of global carbon emissions fluctuate over time. C. To show the importance of distinguishing between different types of carbon emissions. D. To describe different ways carbon is removed from the atmosphere. What aspects of outer space does the professor emphasize? Select two answers. Its vastness. B. Its cold temperatures. C. The absence of life there. D. Its role as the ultimate source of energy on Earth. According to the professor, how do the oceans remove carbon from the atmosphere? A. By dissolving it. B. Through a process of condensation and precipitation. C. By storing the remains of marine animals. D. Through the regulation of air temperatures. Why does the professor mention mining? A. To explain why the price of fossil fuels is continually rising. B. To explain how certain fuel sources can be recovered from the ocean floor. C. To explain why coal and oil are more difficult to obtain than natural gas. D. To explain why fossil fuels contribute to an excess of carbon in the atmosphere. What does the professor mean when he refers to biomass carbon as current carbon? A. It is the fuel source most widely approved by environmentalists today. B. It is part of a balanced system of carbon emission and absorption. C. It is circulated throughout the oceans by the movement of ocean water. D. It readily combines with other carbon molecules to produce long chains. Why does the professor say this? Everyone knows what that is, right? But let's make sure anyway. A. To let students know that the term greenhouse effect will be tested. B. To indicate that the definition of greenhouse effect will be discussed. C. To suggest that his previous definition of greenhouse effect was imprecise. D. To acknowledge that there is controversy surrounding the use of the term greenhouse effect.